In this video, we're going to be looking at how we can find the equation of a perpendicular line to a given equation that has to pass through a particular point. We'll also look at how this needs to be rearranged into a given form. So according to another video that I'll link here, the key features of a straight line can most easily be read when the equation comes in the form of y equals mx plus c, where m is the gradient. The gradient of the line that I've been given is -3. The connection between a line and a perpendicular line is that the perpendicular gradient will be the negative reciprocal of this number, so -1 over m. The negative reciprocal of -3 is a third. An easy way to check that you've got this right is if you multiply the two gradients together. The product of a gradient and a perpendicular gradient will always be -1. So looking at y equals mx plus c and substituting in what I know about the perpendicular line already, I know that y will equal a third of x plus c. I was given a point that this perpendicular line must go through, and I know that when x is equal to 3, y is equal to 7. So substituting in the coordinate, 7 is equal to a third of 3 plus c. Now that I've only got one unknown and simplifying where I can, 7 is equal to 1 plus c, which leads to c is equal to 6. Substituting this into y equals a third x plus c gives me y is equal to a third of x plus 6. So although this is the equation of the line, I need to write it in a given form. The first thing I'm going to do is multiply all terms by 3 to get rid of the fraction. So multiplying all terms by 3 gives me 3y is equal to x plus 18. Subtracting x from both sides gives me -x plus 3y is equal to 18. This is my final answer. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. So looking at the equation of the line that I've been given, y is equal to 8 minus 6x, I can see that the gradient is -6. That means that the perpendicular gradient will be -1 over m, which will be a sixth. As a check, -6 times a sixth is -1, so I know that I've got the right perpendicular gradient. Substituting what I know into y equals mx plus c, I know that the perpendicular line will have an equation y is equal to a sixth x plus c. I know that this line has to go through the point 6, -8, so that when x is equal to 6, y is equal to -8. So substituting the coordinate in, -8 is equal to a sixth of 6 plus c. Simplifying, a sixth of 6 is 1. Add on c is equal to -8, and this leads to c is -9. Substituting this into the equation, y is equal to a sixth of x minus 9. Multiplying all terms by 6 gives me 6y is equal to x minus 54. Subtracting x from both sides gives me -x plus 6y is equal to -54. Although I've got it in the right form, one of the things I can do is multiply all terms by -1 and show that if you also had x minus 6y is equal to 54, this would also be a valid answer. So either one of these would be my final answer.